All right, so we're going to look at wrapping up section 2.7 today. So this is 2.7 example 3, and we've got really continue with what we learned, but we're going to kind of rely mainly on graphing today and using either the graph calculator or Decimals app to get these solutions. You're going to find this is generally going to be your most efficient way to do these styles of problems versus, like factoring and stuff we did the other day. So here we've got Andrew. Kicks the ball up a hill for his dog Leica to chase. So kicks the ball up the hill, the line's the hill, here's the path of the ball. And it says it's modeled by the quadratic function as shown. So it's got the equations here for both the hill, which is just a straight line, and the path of the ball, which is a parabola. And question is, how far does the ball travel horizontally, and how far up the hill must he run to catch it? So the question's asking for this point. How far is the horizontal distance, and how far is the vertical distance or the height of the hill? So if we can find the coordinate right here, we basically have our answer. So we want these intersection points. Now this one is going to be 0, 0. We don't really care about that one. That one's kind of obvious. This is the one that we want. So of our two solutions, we're going to find that one. So I'm just going to rewrite these because they're hard to read there. So we have negative 0.5 x squared, and then that is that plus or a minus? Pretty sure it's a plus. We'll see when we graph it. But so plus 6x, and then the y equals the 0.5x. Now at this point, we could go ahead and set these equal and try to go substitution and do factoring or do quadratic formula if we wanted to. But at this point, like I've kind of talked about, we want to take the most efficient route in most of these cases. So let's go ahead and put this in, and let's see what we're looking at. So this should match what we see on the graph there. Oops, did I not put my square in? I did put my square in. Is that, I wonder if that was supposed to be a minus 6. Hold on, sorry about this. It's hard to read on that, it's faded. All right, hold on a second. Okay, sorry. So yeah, it is a plus 6. I just had to adjust my window. So when I graphed it like this, it looked kind of funky. That's because I just went from 10 to 10. But this graph does need to go like out to, they have it going out to like 25 and up to like 25 also. So you can zoom out and that works fine. But we've talked about the window a little bit before too. So if I go to my window, instead of my X max, instead of having it go up to 10, let's have it go to 25. And then same thing with my Y max. If I change these both to go out to 25, that should show my graph. It should make it match the one that's on my paper a lot better. So yeah, so now we'll see this matches up with that a lot better. So sorry, I didn't look at that. But anyway, here's my point. This is the point that I want. So if I just go ahead and do my intersect feature here, and again, if you're using Decimals, it is easier. You just can click on it. But on the calculator, move it over here, go enter, enter, enter. And here we go. So we have 11 and 5.5 is that coordinate. So 11 and 5.5. Now the other piece to this that's really what I notice tends to burn students the most is what do these numbers mean? So remember, the first number is your X coordinate and the second number is your Y coordinate. So if you read the labels or if you go back and read the problem, you know what these are. So the 11 is the horizontal distance. So we'd say it as a horizontal distance of 11 feet. And it reaches a height of 5.5 feet. One of the most common mistakes I've seen people make on the quiz and the test with this chapter is they get these numbers flipped up. Because sometimes the questions ask you different things. Like this question might just say, what's the height that the ball reaches? And they might not care about this number at all. So you have to read it and realize, okay, they just want the Y value. Or maybe the question just asks about the horizontal distance. So it only cares about the X value. So you have to understand what is the question asking me and then answer appropriately. In this case, they did want both parts though. So that's that. On the next one here, this is another kind of good window type example. So if we look at this one, it says revenue for a band concert is given by this function, and X is the ticket price. So basically saying as you vary the ticket price, it's going to vary your revenue, which makes sense. And it says the cost of the concert is given by this function, again, where X is the ticket price. So by putting in a different ticket price, like charging $2 a ticket or $10 a ticket or whatever, that's going to affect how much it costs to put on and how much it costs or how much you get in revenue. So the question is, At what ticket price will the band make enough revenue to cover their costs? So the idea with this or any business or fundraiser or anything like that is when your costs and your revenue are equal, that's considered your break-even point. So we're looking for when does this value equal this value? But as always, the easiest way to do that is if we graph both of these and we look for their intersection point, that's going to be that break-even spot. Now, I believe when we do this one, it's going to be a little bit hard to find on our window. So let me take a second, get it entered in, and we'll talk about it. Okay, so I went ahead and I typed in my equations here, but I've got this graphed on the standard window right now. And here's the thing, this happens to people a lot, and they get kind of confused and lost, especially when you're using the graphing calculator. Again, this is probably easier on decimals because it's easier to zoom in and out on there. But if you graph it on here, it looks like this. And this doesn't look like what you'd expect because in our equations, we have a quadratic, so that should be a U-shaped graph, and we have a linear because it's just like an mx plus b type thing. So we should have like a U and a line, but they don't show up like that because we're zoomed in really far. Now, if we think about what we know, this is a linear function with a y-intercept at 490. So like it's way up at 490, and then it's got a slope of negative 30. So what we really need to do is we need to go up way higher. So if we know it crosses at 490, we want to go up a lot higher. So make our y max like 500, because then we'll be able to see that y-intercept, we'll be able to see it coming down. So just by changing that number, let's see how that affects things. Okay, so that's pretty good. There's our curve, and then we should have our, yep, there's our line that's at 490 coming in at a slope of negative 30. So actually this is going to work because here's the what would be the revenue, the x squared function, and then here's the cost. So the thing is, when are they equal? There's actually two spots where they're equal. So both of these are going to be solutions in this case. And we want the x value. So if we go ahead and we go find our intersection, move over here. So this intersection would be if they were to charge, and again, this is money, so $2.33 per ticket price, or per ticket. That would be one of them. And then our other one is going to be the point that's over here. Go ahead and slide on over. And this one is 7. Sorry, you can't see that. That's out there, but there it is, 7. So there's actually two ticket prices that are going to give you equal cost and revenue. And that's the $2.33 and the $7. Now, this question doesn't get into it, but if we were, we'd actually want to figure out something. More than likely, the question you'd care about is this, because this is when your revenue is at its highest point. Here's where you're going to be making good money. But actually, you might be able to find a point along here that would actually technically be better because we want the difference of these two to be the greatest. But anyway, this question doesn't ask about that. It just asks for the two spots where they're equal, when the cost and the revenue are the same. So there we go with that. Example 4 is not a standard for us anymore, so you don't have to worry about it at all. So let's go ahead and get that out of there. Same thing with this one. Boom, boom. And let's jump down to example 5. This should be real easy. We've talked about this before. This is exactly what we were doing. You're just going to notice these are going to usually come out to be decimal values. So it says, solve this by writing a system and using the intersect feature of the calculator to solve it. So when they're giving you these, expect decimal answers. Like if they're telling you to use a graphing calculator or decimals to use it, expect decimals. So if we go ahead and we put this in, and we're probably not going to have to do an extra one of these because these are kind of the same skill we've been using all day and that we've already learned before. So if we put in the two equations and we graph this, we're going to look for the intersections. There might be one, there might be two, there might be none. As you can tell, I'm zoomed out. So let's zoom standard again just to get back to normal. See what we're working with here. Okay, so what you got to be careful with here is if you're on your standard window, you see one intersection pretty obviously, but there's definitely going to be another one over here because we have this U-shaped graph. This line's going to cross it eventually. So we should probably zoom out to make sure we can actually see those two intersections because we usually kind of expect two intersections and then we just got to see. Okay, so you can zoom out again or you can see if it'll pick it up. We'll go ahead and try it out. So let's go ahead and do our intersection. So second trace, intersect, and let's just start over here and see if it can pick up this one that's over here. And it can. So we get this value here. And like I said, expect decimals on these. When they're telling you to use a graphing calculator, they're doing it for a reason. Does it tell us what to round to? It does not. So let's go ahead and just go 2 decimal places. So this one is at negative 12.71. And then it is since it is a system, we should include the y value too. So 42.12. So that's one of the solutions. And then we go ahead and just repeat our steps for the other one. And I don't know if I've said it before, but for decimals, you can just click on those points. It'll snap right to it and give you the same thing you want. So 0.71 and 1.87. Okay. So not really a new skill there, but that's the other type of thing here is talking about absolutely sometimes you're going to get decimal values, and that's totally fine. This is just another example of the same thing. I think you should be good on that skill. It's not a new one. And yeah, so that's it.